Okay, now up to now we have been dealing with just functions y equals f of x, and when you take the derivative of it, that's what we've been doing. But what if these two cases, it is not a function, now most of you know a function is it fails, or when it's not a function, it fails the vertical line test. So if you had, say, a circle, okay, that would not be a function because there is, for say this x here, say this is on a, okay, for this x here, there is two different y's, right? And that is not a function. The equation for the circle is x squared plus y squared equals r squared. So when we're not dealing with functions, we're going to have to use what's called implicit differentiation. The other time that we're going to need it is if y cannot be isolated. So if you look at this example here, xy minus y squared plus 5 equals 0. This is, find the derivative of that. Well, all the ones we've been doing up to now are y equals, y equals, y equals, so we got to get this one to y equals. So, I don't know, the first thing I would try is like factor out a y, and that would be x minus y equals, and I'm going to get the negative, or the 5 on the other side to be negative 5. Now, do you see I can't get it to y equals? It's not going to happen. Okay? So this is a situation that we would need to use implicit differentiation. Okay, since y is not isolated. So in such cases, we use a special application of the chain rule, which is awesome because we learned that yesterday, called implicit differentiation. Okay, it must be remembered that y is a function of x. Now, here is the first kind of example. I find them actually harder to follow when they're already written out for you, but just kind of follow along here with me. We need to take the derivative of y cubed, we need to take the derivative of xy, and we need to take the derivative of 7x. So that's what the d over dx in front, that means a derivative of y cubed plus the derivative of xy. Going to use the product rule here, times the derivative of 7x. Now, to take the derivative, now we've never done this before, but to take the derivative of y cubed, you're going to go 3y squared times dy over dx. Plus, here we're using the chain rule, derivative of x is 1 times the second, plus the first times the derivative of y, which is dy over dx, equals 7. Now, when I do these, I just change them right to y prime. So this is probably the more understandable. It would be 3y squared y prime plus y plus x y prime equals 7. Then what you want to do is you want to isolate the y primes, or the derivative dy over dx. So I subtracted x out, or sorry, subtracted y out. You can see there. And then we're going to now factor y prime out, leaving us with this. And then we're going to divide this out. So this would actually be the derivative of this function. Now, do you see how there's x and y's in here? So that's going to change things too when we are solving for the derivative. We need the y, not just the x. Okay? So let's do this one here. Now, when you take the derivative, this is kind of a side thing I just want you to write. I want you to write down 3y cubed. The way you would find the derivative of this would be 9y squared times dy over dx. See, everything is done with respect to x. Now, before, we were doing like 3x cubed. We were doing these before. How come we didn't have that thing written after it? Well, we kind of did. So we were doing 9x squared times dx over dx. And what is dx over dx? This is 1. So we weren't putting it in there because it's always 1. See, when you take the derivative of x with respect to x, it's a waste of time. Okay? It's 1 every time. But when you take derivative of y with respect to x, you're going to have to put it down. Okay? And that's the only habit you're really learning today. The chain rule is the chain rule. And I kind of did the chain rule here. See, I did the outside, and then I did the derivative of x with respect to x, which is 1. This one with the chain rule, though, you're going to have to put dy over dx. Or you can put y prime. Okay? So if we do this one here, to do the derivative, we're going to do it using the dy over dx just for the first one. So this would be 3y squared dy over dx minus, now I've got to use the chain rule here, or sorry, the product rule. Okay, so it's the first times the derivative of the second would be dy over dx plus the second, which would be y, times the derivative of x is, well, actually, sorry, it should be just 3, right? Derivative of 3x would be 3. Plus 2y dy over dx equals 2x, and you don't have to put dx over dx. It's just 1. If you wanted to put that every time, you could. Yes. Okay? I'm not going to go on until everyone's kind of see what I did. So I used the chain rule for every y, and I put dy over dx. Now, we can rewrite dy over dx as just y prime. So from now on, I'm not going to do this step anymore, the one before it. I'm just going to go straight to here. I do find it a lot easier. Minus 3x y prime plus 3y plus 2y y prime equals 2x. Now what do we need to isolate? Y prime. Okay? So first thing I'm going to do is get rid of the 3y. So I have 3y squared y prime minus 3x y prime plus 2y y prime equals 2x minus 3y. Now, since everybody has a y prime in it, I can pull it out, and that would be 3y squared minus 3x plus 2y equals 2x minus 3y. Okay. And the last thing is to isolate y prime is to divide that set of brackets out. So y prime would equal 2x minus 3y all over 3y squared minus 3x plus 2y. So when do we do this? When you can isolate y, and or if it is not a function. Hmm? Yeah, when you can't isolate y or when it's not a function. Okay, yep. Yeah, so you're up here. Yeah, I could have done this right from the beginning if I wanted to. Is that what you're thinking? Okay. Yep. Yes. Yes, you're right. Yeah. Yeah, I just want to double check. Yep. So this should have been a minus here. Oops, no. Sorry. So now that if I was to take that out, yeah, that would have been a minus. So that's a plus 3y. Yeah, it's a good catch. Because this is all the chain rule, or not, sorry, the product rule. So yeah. Okay, that's good. Okay. So this one here, let's go right to just deriving it with the y primes, okay? So the derivative of y would just be y prime, okay, minus, and let's not make that same mistake again. Let's get a bracket. And this would be, so let's go first, times the derivative of the second would be 3y squared y prime plus the second times the derivative of the first would be 2x equals 1 plus 2y y prime. Okay, Now, let's just get rid of the brackets. X squared 3y, y prime minus y cubed 2x equals 1 plus. And that's what we should have done on that last one that I missed there. Okay, so same old thing, right? Let's get the y primes on the left. So I'm going to subtract that. Yeah, make another mistake. Oh yeah, there it is. Fell off. Okay, so let's do y prime minus, I'm going to put that 3 in the front, 3x squared y prime equals 1 plus 2y prime. Oh, crap. I got to get that on the other side. Minus 2y prime equals, if I want everything out of here, so I had to get this on this y prime, I had to get it on the left. I forgot it was over there. Now I've got 1, and I'm adding y cubed 2x, or 2xy cubed, whatever. Okay, so that one y prime that was hanging out there on the right, that term, I want to get on the left with its buddies, and I got everything else. It doesn't have a y prime in it on the right. Then we'll go through the same old scenario of taking out the y prime, leaving me with 1 minus 3x squared. Okay, so y squared, right? I feel like I made a mistake here somewhere. 2x squared, y. Okay, am I doing good so far? Do you see anything? I'm going to change this to 2x y cubed. Okay, does this look good? Did I make a mistake? Okay, so then y prime should equal 1 plus 2xy cubed all over 1 minus 3x squared y squared minus 2y. How's that look? Okay, now this is the first time we're actually going to apply it, and then you'll see how it works to be able to find the slope. Now, all the other ones, we needed just the x value. You can see that on the right side of many of these, you got x and y's. So to be able to find the slope, you're going to need both x and y's, and they give us it. Now, you could, no, so this is very hard to actually find because of the fact that you can't isolate y. So even if they gave you x, it's very hard to find. This one wouldn't be bad, but when you have y's scattered all over the place, like example 3, it would be hard to find y on your own. So this one here, let's kind of just do it together. So just walking along, what would be the derivative? 2x minus 10 y prime equals 0. Good. Derivative of negative 1 is 0. Okay. So now we have negative 10y, y prime equals negative 2x. You can divide the negatives out too, and you'd get y prime equals 2x over 10y, which would equal x over 5y. Okay, and now we just have to sub in our point, negative 2, negative 1. So the slope would equal negative 2 over 5 times negative 1, which equals 2/5. Okay. Now example 5 is really going to, I think, help solidify all this stuff because you'll have a picture to look at as well. Everyone got that down? Okay, so it says, find the equation of the two tangent lines to x squared plus y squared equals 169 at x equals 5. Sketch your answer and answer in general form. Okay, now if you've done enough of these, you can already tell that I'm going to have x and y's in my solution. So I'm going to need to know what y is, but we can, when we come to that point that we see, oh, okay, we need it, then we can go look for it, because they weren't very nice and they didn't give it to us. Now, this is a equation of a circle, x squared plus y squared equals r squared. So if it's r squared, what do you think the r stands for the radius? What do you think the radius is? So r would equal 13. Okay, and we used to have to teach this whole conics unit in. But the center of this circle is 0, 0. So let's just draw a circle like that. And let's see how good yours is. It's harder to do it on a smartboard than on paper, though. Okay, so that makes sense to everybody so far? And 5 would be about, I don't know, about there. There's 5. So we've got this point here and this point here that we are doing tangents to. Oop, that's not a very good tangent. That's a crappy circle. That's why. Okay.
Please excuse the interruption. Could all grade 10 students going to the play please head to the atrium? Thank you.
Okay, so that's what I'm trying to find. I want to find the equations of those two lines. Now, since I think we can think, since, well, yeah, we got to find the equation of a line, I do need the y. So why don't we find the y value right now, and that way we can even put it into our diagram. So if we have 5 squared plus y squared equals 169, 25 plus y squared equals 169, y squared equals 169 minus 25, y squared equals 144. Therefore, y is plus and minus 12. So, 5, 12, 5, negative 12. So to be able to find the equation of a line, you need the x, you need the y, and you need the slope. So the way we're going to find the slope is by doing a derivative of our equation. So I got x squared plus y squared equals 169. Derivative would be what? 2x plus 2y, y prime equals, no, you can't do that because of the plus sign. Equals 0. Okay, so 2y, y prime equals negative 2x. Y prime equals negative 2x over 2y. Y prime is negative x over y. Okay, so let's find slope at 5, 12. So y prime equals m, right? M stands for slope, equals negative 5 over 12. Okay. So the equation of the line at 5, 12, we'll just keep going this way, will be y minus 12 equals negative 5 twelfths times x minus 5. Okay, if we multiply everybody by 12, right, we'll have 12 y minus 12 equals negative 5 x minus 5. 12y minus 144 equals negative 5x plus 25. Okay, if we bring that all to the left, we'll have 5x plus 12y minus 169 equals 0. Okay, that's the equation of the line at the tangent at 512. Okay, to do the last one, we're going to do the slope. So the other tangent at 5, negative 12. So y prime equals m would be negative 5 over negative 12. That would just be 5 over 12. So y minus 12 equals 5 twelfths times x minus 5. Multiply everybody by 12. Y minus 144 equals 5x minus 25. Oh, crap. That should have been a plus 12. Because I put my negative 12 in this time. What am I doing here? Okay, so then I will get negative 5x plus 12y plus 169 equals 0. We shouldn't have a negative in front of the first one, so it'll be 5x minus 12y minus 169 equals 0. No, you divide everybody or multiply everybody by negative 1. I didn't actually factor it out. I just multiply because there's 0 on the other side. Okay, so it's just a little bit of a difference, right? You're always, if you have to take the derivative of y, make sure you put dy over dx or y prime. But if you're taking the derivative of x, you do not have to put dx over dx. Okay, so just something to keep straight on a study sheet. And there you go. There's your homework. 1 AC, 2 AC, 3 AC, 5, 7 AB, and 9.